Hello learners, I am Dr. R.B. Malati, Assistant Professor at Chhattisgarh Swami Vivekanand Technical University, Bhilai. I welcome you all again to the course Fundamentals of Building Construction. In this lecture on plastering and pointing, we are first going to talk about plastering. What is plastering? In a simple language, we can say it as a practice that transforms rough surfaces into smooth and durable one. This involves covering walls, columns, ceilings or other parts of a building to achieve a flawless finish. And when we apply this plastering to external surfaces, we call it as rendering. So, why is plastering so essential? Well, it serves several key functions. It offers protection, keeps things clean, adds a decorative appeal, resists vermin and even conceals any imperfection or flaws. With this outset, let us first look into the different types of the mortar used in plastering. We have lime mortar, which is a composition of lime and sand in the ratio of 1:2. Then cement mortar, which is a composition of cement and sand in the ratio of 1:3. And lime cement mortar, which is a composition of cement, lime and sand in the ratio of 1:1:6 or 1:2:9. So, now let us discuss each one of this in detail. First up, we have lime mortar. This one has been used for centuries, especially in older buildings. It is great because it is flexible and allows the walls to breathe, which is important for structures made of materials like brick or stone. And the lime used for plastering in this can be either fat lime or hydraulic lime. Generally, fat lime is preferred for plastering because it yields good putty after slacking. Here, what does slacking mean? Slacking is nothing but the process of adding water to lime to create a smooth and creamy putty. Okay. Getting back to the process, fat lime is our choice and it is slacked wet, which makes it easy to mix and work with. The mix proportion for fat lime here is usually between 1:3 or 1:4, that is lime to sand ratio. Now, hydraulic lime, it is bit different. It contains particles that slack very slowly when they come into contact with the atmospheric moisture. This slow slacking can continue for 6 to 8 months. Imagine waiting that long for your plaster to settle. Quite difficult, right? Again, if unslacked particles remain in the plaster, they can form blisters during the slow slacking process, which damages the surface. So, now this hydraulic lime does yield a harder and stronger surface compared to flat lime. Few things that you have to remember while using hydraulic lime for plastering is it should be ground dry with sand. Then it is left for 2 or 3 weeks and reground before use, and the mix proportion usually we consider here is 1:2, that is the ratio of lime to sand. And now we can also improve the binding properties of the lime mortar by adding certain materials. For example, adding guggle, nothing but the resin of the salai tree, at a rate of about 1.6 kg per cubic meter of mortar can enhance the binding properties. We can also improve the adhesive and tensile properties of lime mortar by adding in some chopped hemp, a plant used to make rope and strong rough clothes, at a rate of about 1 kg per cubic meter of mortar. This helps to prevent the formation of tensile cracks on the plastered surface. Next, there is cement mortar. This type is tough and resistant to water, so it is perfect for outdoor areas or places that get damp. It is stronger than lime mortar and can handle rough weather conditions without breaking down. Just visualize the skyscrapers in Dubai or resilient buildings in Tokyo. These structures showcases the importance of cement mortar. The mixed proportion of this varies from 1:4 to 1:6. The important things that we have to consider is, for the best result, The sand we use here should be clean, coarse and angular. The mortar should also be dry mixed before water is added and must be used within 30 minutes to ensure it sets correctly. That is pretty fast, right? And then we have lime cement mortar. Adding lime to cement mortar enhances its workability, making it easier to apply. Generally, mixed proportion of 1:1:6, that is cement of 1 part, lime of another 1 part and sand of another 6 parts, and also 1:1:8 or 1:2:8 are used. Here we conclude the types of mortar used in plastering. Now, let us look into the plastering terminologies. There are nearly 17 and let us look one by one slowly. First is background. Have you ever wondered what the background means in plastering? It is simply the surface where the first layer of the plaster goes. Simple. Next, the blistering. These are the local swelling on a plastered wall. They happen because of leftover unslacked lime nodules. Third, cracking. When you see fissures in plaster, that is cracking. It usually happens due to the movements in the walls or surface behind it. Next is creasing. Imagine tiny hairline cracks all over a surface. Those are creasing cracks, adding an irregular pattern to the plastered finish. Next, dado. The lower part of the plastered wall is known as dado. If you notice, this needs special treatment to make it tougher and more resistant. Next, we have dots. If you have ever noticed small plaster projections on walls, those are dots used to anchor other elements like screeds firmly in place. Dubbing coat. This is done before the main plaster goes on, and any hollow spaces in the wall gets filled up with a dubbing coat to ensure a solid base. Next, at the 8th position, we have finishing coat. The very last layer of plaster is known as a finishing coat, also called as a setting coat or skimming coat. It is what gives a surface that smooth final touch. Then the flacking. If you notice that patches of plaster start peeling off, that is flacking. Then we have gauging. Gauging is like mixing a recipe for plaster, getting the right mix of materials to achieve the perfect consistency. Next is grinning. Sometimes you might see patterns from the wall joints showing through the plaster. That is grinning and it affects the surface appearance. Next, grounds. Grounds are wooden steps fixed to the background to which primary finishing may be secured. Then hacking. Hacking starts before plastering starts. It is a process in which the wall gets roughened up. It helps the plaster stick better. Then the keys. These are like little anchors in the wall opening or rough spots that helps the plaster grip onto the surface. Latents. When concrete or mortar gets traveled too much, it forms a thin layer on top called latents. It needs to be removed before plastering. The last two, that is peeling and undercoats. Peeling is the dislodgement of plaster work from the background, and undercoats, these are the coats of plaster applied under the finishing coat. Having understood the various terminologies, let us now see the essential tools used in this plastering work. Imagine a small, precise tool designed for measuring just the right amount of plaster mix and applying it with the finest to corners. That tool is called gauging trowel. The blade can be pointed or bull-nosed, giving you options for different application needs. Next comes the float that you see in the figures. This versatile tool comes in two main types. Metal float, also called laying trowel, made from thin, tough steel. It is perfect for laying down the initial layer of the plaster and achieving a smooth finish. The blade size typically ranges from 10 cm by 30 cm, ensuring you to cover areas effectively. And the next type is wooden float, also called skimming float. Crafted from wood, this float is all about fineness. It is used for applying the final coat of plaster, and the sizes of this vary from 10 cm by 30 cm to 11 cm by 33 cm, which is a thickness of 10 to 12 mm. And don't forget, there is another interesting float that was not counted earlier, that has a tiny nail projection of 3 mm called the devil float, also called the hand float. It is great for creating zigzag patterns that helps the next coat stick better. Next, under essential tools falls the floating rule. This tool is like your trusty leveler, ensuring that every plastered surface stays perfectly even and level between each grade. It is essentially for maintaining consistency across the job. Finally, there are some miscellaneous tools also. From the plumb bob to the spirit level, set square, straight edges, brushes and scratchers, each tool plays a unique role in presenting your plaster work. They ensure your walls are straight, corners sharp and textures just right, making a perfect partner in the craftsmanship. So, having understood the essential tools, let us look into the specifics of plastering coats and how they help to achieve the required finish. Now, depending upon the type of the wall construction, whether it's a random rubble masonry, core rubble masonry, brickwork or cement block work, plastering requires different thickness and number of coats. Typically, plastering is applied in 1, 2 or 3 coats, and applying plaster in a single coat usually reserved for less important application due to the risk of heavy shrinkage and cracking. For good result, lime plaster generally involves 3 coats, whereas cement plaster typically uses 2. Indian standard recommendation outlines the number of coats required for various backgrounds. For instance, stone masonry might need either 2 or 3 coats, while brickwork or hollow clay tiles can be covered with 3, 2 or even 1 coat, depending upon the requirement. Similarly, this concrete cast inside, we have to go for 2 or 1 coats, and building blocks 3, 2 or 1, wood or metal lathe needs 3, fiber building board needs 2 or 1, wood wool slabs need 3 or 2 and cork slabs need 2 or 1. So, the first coat, known as the undercoat or rendering coat, serves to level uneven surfaces and seal the wall against rain penetration. It is thicker, ranging from 10 to 15 mm, providing a solid foundation for subsequent layers. The second coat, called the floating coat, further smoothens the surface, usually applied at a thickness of 6 to 9 mm. Finally, the third coat, known as setting or finishing coat, adds the final touch of smoothness with a thin layer, typically 2 to 3 mm thick. Now, it is important to know how to prepare and apply those coats for a smooth finish. So, in the methods of plastering, first off, preparation of background is important. For new surfaces like brick or stone masonry, joints are racked to create a key for the plaster, about 10 mm for brick and 15 mm for stone. Any mortar droppings, dust or latents, which is simply a thin layer on fresh concrete, are cleared off with a stiff wire brush. We level out any uneven spots before applying the plaster. Then, depending on whether we are aiming for a 3-coat or 2-coat plaster, we keep projections and depressions within specified limits. And for 3 coats, this projection shouldn't exceed 10 mm and depression 20 mm, while for 2 coats, it is 5 mm and 10 mm respectively. Having understood the general step, now let us consider lime plaster as our first choice, which can be applied either in 3 coats or 2 coats. Before the application of the plaster, the background is prepared as just discussed. Okay. Implementing the 3-coat process as our first choice on lime plaster. First step is rendering coat. This first coat is all about laying down a solid foundation. We apply the mortar with a mason's trowel, pressing it into joints and the surface to cover any irregularities, usually around 12 mm thick. After it sets a bit, we scratch it crisscross to improve adhesion and then let it cure for about 7 days with damp curing before drying completely. Next is floating coat. Once a rendering coat is clean and lightly wetted, we apply patches or strips as gauges. Then we throw mortar onto the surface with a mason's trowel, spreading and rubbing it smooth with a wooden float to ensure an even surface. Thickness here varies from 6 to 9 mm. And lastly, finishing coat. This final layer involves applying a cream of lime, also called Neeru or plaster's putty, with a steel trowel, rubbing it smooth and letting it dry thoroughly. In lime surki mortar, this coat comes 7 days after the floating coat, cleaned, wetted and then finished smooth. Here we finished the 3 coat. Now, in the case of 2 coat plaster, earlier it was 3 coat and now it is 2 coat plaster. The rendering and floating coats are combined in one continuous operation, skipping the scratching step from the 3 coat method. The total thickness is about 12 mm, followed by a similar finishing process as that of the 3 coat method. There where the process with lime mortar as our first choices worked out. Okay, let's move to the cement plaster and cement lime plaster, where we will learn how these materials are applied and different coats for various types of surfaces. A cement plaster can be applied in either 2 coats or 3 coats, with the latter being less common. So, 2 coat plaster. Again, we prepared the background by racking joints about 20 mm deep, cleaning the surface thoroughly and ensuring it's well watered. If the surface is uneven, a preliminary coat fills in all hollows before the first coat. Next comes the interesting part. The first coat or rendering coat is applied just slightly thinner than the specified thickness of the plaster. To keep it uniform, we form screeds on the wall surface using dots spaced about 2 meters apart. These dots are plumbed vertically using a plumb bob, and then mortar is applied between them to create vertical steps known as screeds. This ensures a consistent thickness of our plaster. And before this rendering coat sets too hard, we give it a good working over to create a mechanical key for the final finishing coat. This coat stays down for a couple of days before drying completely. Finally, the finishing coat around 2 to 3 mm thick is applied with wooden floats to ensure a smooth, even surface, finishing up with steel trowels to eliminate any joining marks. So, that's how 2 coat plastering is done with the cement plaster. Now, if we look into the 3 coat plaster method here, it is quite similar to the 2 coat process we just saw, but with an additional intermediate coat known as the floating coat. Here is a breakdown of this method. The rendering coat, a bit rougher, is applied first about 9 to 10 mm thick. After about 4 to 7 days, we come back with the floating coat, which is thinner, around 6 to 9 mm, smoothing things out even more. Then, within about 6 hours of applying the floating coat, we finish it off with the final coat, 2 to 3 mm thick, using the same method as that of the 2 coat plaster to get that sleek polished look. Lastly, the single coat plaster, chosen if you are okay at the inferior quality work. Here, just 1 coat is applied, much like the first coat of the 2 coat plaster. We finish it off immediately after it hardens enough, ensuring it as smooth and consistent as possible. Beside all three, when we look into the traditional practice of plastering over lathe, we have to keep in mind that we are talking about laying down a solid foundation for smooth wall and ceilings. And the slates may be either wooden or metal. Wooden laths are strips about 25 mm wide and 1 to 1.5 meter long and are perfect for wooden partitions and ceilings. They are neatly spaced in parallel lines with about 10 mm between them, firmly nailed with galvanized iron nails, whereas metal laths, which is another option, are fixed using GI staples. And if the surface is concrete or masonry, wooden plugs are embedded to anchor the lathe securely. Once the lathe is in place, it is time for the plastering work, typically done in 3 coats using cement mortar. This method ensures a proper base that can withstand the test of time, providing a smooth and durable finish for our walls and ceilings. There we end the methods of plastering with various materials. Now comes the finishing. Yes, when it comes to finishing plastered surfaces, there is a variety of options to achieve the look and durability you actually desire. Let us look into these finishes that can transform your walls and exterior so beautiful. First up, we have the smooth cast finish. This method yields a sleek level surface using a cement and fine sand mix, typically in the ratio of 1:3. Applied with a wooden float, this finish avoids using steel floats for exterior application to prevent potential cracking and creasing over time. Next, there is a sand face finish. Achieved over 2 coats, the first layer is a 12 mm thick mix of 1:4 cement to sand ratio marked with zigzag lines. After curing for a week, the second 8 mm coat uses a finer 1:1 with perfectly screeded sand. The surface is then finished by rubbing clean, uniform sand into the final coat using a wooden float, ensuring consistent grain density. Moving on to the rough cast finish or spatter dash finish. This option adds durability and water resistant. The final coat includes a mix of cement, fine sand and quartz aggregate in the proportion of 1:1.5:3. Dash onto the prepared surface with a large trowel. It is roughly finished with a wooden float to create a robust exterior finish resistant to cracking and creasing. Then, for those looking for a modern textured appearance, there is a pebble dash finish. Here, a 12 mm thick final coat of 1:3 cement to sand mix is applied. Clean pebbles ranging from 10 to 20 mm in size are then dashed against the surface and lightly pressed in with a wooden float, creating a durable finish. And the unique option is the depth finish, similar to pebble dash but with pieces of gravel or flint pressed into the wet surface. This allows for creative patterns using different colored flints, adding aesthetic appeal alongside durability. Again, if you prefer a more decorative approach, the scrap finish might be of your choice. After applying a 6 to 12 mm thick final coat, the surface is scraped in patterns to a depth of 3 mm once it is stiffened. This technique, using tools like steel straight edges or old saw blades, not only adds structures but also reduces the livelihood of cracks. Lastly, there is a textured finish used with stucco plastering. This involves creating ornamental patterns or textured surfaces on the final coat of stucco plaster using suitable tools, allowing for intricate and personalized designs. Having seen the finishes that transform your walls, let us look into the special materials that plays an important role in enhancing the durability, appearance and functionality of the finished surface. First is acoustic plaster, which is designed to absorb sound. This type of plaster is typically applied in 2 coats, each 6 mm thick using a wooden float. It undergoes a chemical reaction that forms tiny honeycombed opening, making it ideal for interior walls in places like halls and auditoriums where sound absorption is very important. Next, there is asbestos marble plaster. Crafted from a mixture of cement, asbestos and finely crushed marble, this blend imparts a luxurious marble-like finish, enhancing the aesthetic appeal of plastered surface. Then for specialized environment such as X-ray rooms, barium plaster is employed. Made from cement, sand and barium sulfate, this plaster helps protect individuals working in these areas. Then we have granite silicon plaster, which is used in superior construction, and another important one is gypsum plaster. It is a widely recognized material in plastering and is also commonly known as plaster of Paris. It hardens rapidly upon mixing with water and is used extensively in combination with lime for ornamental work and repairs. Gypsum plaster is valued for its fire resistant, lightweight nature, sound insulation capabilities and its ability to adhere well to the fibrous materials. However, it is soluble in water, limiting its use in the interior application. Next, keen cement plaster derived from calcining plaster of Paris with alum produces a hard polished surface that is ideal for angles, skirtings and decorative plastering due to its glass-like finish. Similarly, we have Martin cement plaster created by calcining pearl ash with plaster of Paris, sets quickly to form a durable white surface suitable for internal finishing work. We also have Parian cement plaster, which is cheaper than the keen cement used for the interior work. Next, we have Scagliola plaster, which offers an elegant alternative resembling the marble made by keen cement and coloring pigments in glue. It is often used for decorative elements like pilasters, panels and columns. We also have Seraphite plaster formed by slacking plaster of Paris in petroleum. This sets quickly and boasts fire resistant properties, producing a hard white surface upon drying. Last before, we have Snowcrete and Colorcrete cements. These are the trade names given to white and colored cement respectively. These are used on external walls to create good appearance. Finally, Dissolve hard wall made from high grade gypsum that sets rapidly to deliver an excellent finish for interior application, and it is known for its efficiency and durability in plastering projects. So, here we conclude special materials used in plastering. Now, similar to any topic, even in plastering, it is important to know that finishing walls and ceilings can have defects that affect how they look and last. One common issue is blistering, where small patches of plaster swell beyond the surface due to delayed slacking of lime particles within the plaster mix. This often results from improper mixing or curing processes. Next is cracking. Cracking is a significant defect that appears as fissures in the plaster. The causes of this include inadequate preparation of the wall surface, structural faults in the building, uneven application leading to discontinuities, and movements in both the background and plaster surface due to factors like thermal expansion or rapid drying. Hope you remember that gypsum plaster can expand while lime sand plaster may shrink excessively if applied too thickly. Next, we have creasing that adds an irregular pattern to the plastered finish, which manifests as a hairline crack across the surface similar to the cracking but on a smaller scale. The causes of this are the same underlined for cracking. Next, efflorescence. Efflorescence is something you have probably noticed in swimming pools. Here, chemicals in the pool water reacts with the plaster or concrete, leading to salt deposits on the pole walls. This not only spoils the look but can also make it harder for paint to stick. You often have to wash it off repeatedly to keep things looking good as you expect. Flacking occurs when successive layers of plaster fail to bond adequately, resulting in loose patches that can easily detach from the underlying surface. Then we have peeling. Peeling goes a step further than flacking, where entire section of plaster detach, leaving noticeable patches. This defect is also attributed to poor bonding between layers. Then popping, which you often notice in buildings located at varying climatic conditions. It refers to the formation of conical holes in the plaster surface caused by particles that expand during the setting process, disrupting the smooth finish. Next, rust stains. Rust stains may also be seen mostly in industrial structures. This appear when plaster is applied over metal lathe, where the interaction between metal and the moisture causes discoloration. Lastly, we have uneven surface, which is a result of poor workmanship. So now let us conclude plastering here. One thing that you should have in mind is meticulous attention should be given during preparation, application and curing phases of plastering projects, ensuring surfaces are properly treated and materials are applied according to recommended practices to mitigate these common issues effectively. Next, moving to the next part of the module, that is pointing. Pointing is also important in masonry construction as it enhances both the appearance and durability of exposed joints, preventing water ingress and maintaining the structural integrity. The process involves racking joints to a depth of about 10 to 20 mm and filling them with a high quality mortar tailored to the specific type of bonding desired. Just like plastering, we use lime and cement mortar here too. If we use lime mortar, you mix 1 part of lime with 2 parts of sand or surki. This is made by grinding fat lime in a mortar mill. If you use cement mortar for pointing, the mixed ratio you have to choose is 1 part of cement to 3 parts of sand. So, what would be the step in preparing this for masonry? When preparing for new masonry, we rack the joints while the mortar is still soft. After that, we clean them thoroughly and make sure to wet them completely. For existing masonry, we remove old pointing and any extra mortar. Then we clean the joints and wet the surfaces in the same way. But the technique may vary to achieve different finishes. If you see the flush pointing, it involves pressing mortar into the joint, finishing it flush with the masonry units, edges for durability against dust and water accumulation. Then the recess pointing. Recess pointing sets the mortar back from the edges, enhancing appearance while maintaining durability. We can also do rubbed, keyed or grooved pointing. This modifies the flush pointing by creating groove at mid height, improving the aesthetic. This is seen in historic building like our Parliament building is a good example of this. Beaded pointing uses a concave tool for a decorative appearance, though it can be fragile. Struck pointing inclines the pointing face, aiding water drainage. Tuck pointing initially flushes mortar into joints, then cuts a groove filled with white cement putty for added visual appeal, mostly seen in urban areas. We have V pointing, which creates a V groove for distinctive detailing. Finally, we have weathered pointing, which forms a V-shaped projection, enhancing the water runoff. This ends the pointing. So, there you have it. Today we learned plastering and pointing in building construction. We understood plastering works like a magic that transforms rough surfaces into smooth, durable finishes. we explored different types of mortar used for plastering, such as lime mortar, cement mortar and lime cement mortar. Each type has its own unique properties and application. We also covered essential terminologies in plastering like background, blistering, cracking and others. We also understood tools such as gauging tools, floats and floating rules play key roles in achieving precise and even finishes. Moving on to the plastering coats, we also discussed how they vary based on the type of the surface and the finish desired. Whether it is a single coat for simpler application or multiple coat for the robustness and aesthetic appeal, each layer serves a specific purpose in creating a flawless end result. Finally, we explored common defects in plastering such as blistering, cracking and efflorescence. Then we moved to pointing. We looked at different types of pointing techniques including the flush pointing, recessed pointing, rub pointing and much more, each offering distinct visual and functional benefit. This concludes our lecture on plastering and pointing. Thank you for joining me today in exploring the fundamentals of building construction. Happy learning. Good day.